Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 37, a Delta IV rocket is fueled and ready to launch the AFSPC mission for the United States Air Force. Good morning and welcome to Mission Control at Cape Canaveral Air Force Station in Florida. I'm your host, Andrea Lenhoff. I'm a parts, materials, and processes engineer focusing on additive manufacturing, also known as 3D printing, at the United Launch Alliance. Our 65-minute window opens at 12:47 a.m. Eastern Time, with a slated launch time of 12:52 a.m. Eastern Time. Coming up in a few minutes at T-minus 4 minutes, the launch count will enter a planned 10-minute hold. This planned hold gives the time team to conduct final systems checks and resolve outstanding issues prior to entering the terminal count. Again, at this point, the team is not working any issues. At the request of our customer, today's live mission coverage will conclude following confirmation of payload fairing jettison, which is scheduled to take place about 4.5 minutes after liftoff. Kathy Winters, the 45th Space Wing Weather Officer, recently provided us with a final weather forecast, and the weather is within the launch commit criteria. The probability of violating launch constraints is 0%. The winds are 4 knots out of the east, and the temperature is 81 degrees Fahrenheit. So with that favorable forecast, we are proceeding towards a planned T0 of 12:52 a.m. Eastern Time. This is Delta Mission Control. Today's flight will deliver 2 geosynchronous space situational awareness program satellites to orbit. Built by Orbital Sciences Corporation, the twin GSSA program satellites will support U.S. Strategic Command space surveillance operations and the Joint Functional Component Command for space by collecting space situational awareness data, allowing for more accurate tracking and characterization of man-made orbiting objects. With unobstructed and distinct vantage points for viewing resident space objects orbiting Earth, the data gathered will uniquely contribute to timely and accurate orbital predictions, enhancing our knowledge of the geosynchronous orbit and environment, and further enabling space flight safety, including satellite collision avoidance. For most of our missions, our customers provide us with artwork for the payload fairing. Let's take a look at today's artwork. The triangle, in Air Force blue, represents the Delta rocket. The black to gray shading is the rising sun seen from space. At the top of the triangle is the Roman numeral for 2016, while on the inside we see the Latin phrase, "We see everything." The 2 flying owls represent the twin spacecraft. The sitting owl and the wing cutout represent the twin spacecraft from the AFSPC mission. Finally, 3 stars signify the mission partners, Los Angeles Air Force Base, Patrick Air Force Base, and Orbital ATK. In case you're wondering, AFSPC is an acronym for Air Force Space Command. Air Force Space Command is headquartered at Peterson Air Force Base in Colorado. Their mission is to provide resilient and affordable space and cyberspace capabilities for the joint force and the nation. Today's flight will take a southeasterly heading away from our launch pad here at Cape Canaveral. Let's take a look at what else we can expect to see today.
The following profile details the important events of this mission using approximate times.
6, 5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV rocket.
The Delta RS-68A main engine and 2 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 44 seconds. At 57 seconds, the vehicle reaches maximum dynamic pressure. At 1 minute 40 seconds, the solid rocket motors are jettisoned. Approaching main engine cutoff, the Delta IV is burning propellant at the rate of approximately 1,000 pounds per second, flying at more than 85 miles in altitude, 234 miles downrange, and traveling at nearly 11,700 miles per hour. Booster engine cutoff occurs at 3 minutes 58 seconds. 6 seconds after booster engine cutoff, the first stage is jettisoned. Second stage engine ignition takes place at 4 minutes 18 seconds. At 4 minutes 29 seconds, the payload fairing is jettisoned.
ULA is using the Delta IV Medium Plus 4.2 rocket to launch AFSPC. This is the 33rd Delta IV launch and ULA's 110th mission. Built in Decatur, Alabama, the Delta IV Medium Plus 4.2 includes a common booster core powered by an Aerojet Rocketdyne RS-68A engine and 2 ATK solid rocket motors. An Aerojet Rocketdyne RL-10B2 engine powers the Delta cryogenic second stage. A 4-meter diameter payload fairing protects the twin satellites during ascent. On August 5th, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, at Space Launch Complex 37 and mated to the Delta IV rocket. Approximately 7 hours ago, final preparations began at Space Launch Complex 37. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the 10 million pound MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. Using a carriage transporter system traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its park position 345 feet north of the Delta IV rocket. The Delta IV rocket stands 206 feet tall, or about 20 stories high. The RS-68A main engine and 2 solid rocket motors combine to produce more than 1.2 million pounds of thrust at liftoff. About 4 minutes later, at stage separation, it weighs just 10% of what it did at liftoff. Today's launch is in memory of Ramey Hill. In 1999, at age of 19, Ramey began his career at the Decatur production facility. He was a member of the final assembly team responsible for the final assembly, test, and shipment of the Delta IV Common Booster Core. For everyone that knew Ramey, it was common to hear him talking about his family, especially his 2 daughters, Lily and Lila. Outside of work, Ramey enjoyed fishing, hunting, riding 4-wheelers with his girls, and spending time with his wife, Rhonda. Ramey was a wonderful father, son, husband, friend, and co-worker who will be greatly missed.
Enable.
P&E, launch enable to enable.
Enable.
GE, launch enable to enable.
Enable.
OSM, launch enable to enable.
Enable.
LC can verify TC ESCS panel configuration. And LC verifies TC or enable is on.
-5 minutes.
Timer at T-minus 4 minutes. Verify the sequencer is holding.
Roger.
This is Delta Mission Control. We are about to enter the planned 10-minute hold.
T-minus 4 minutes and holding. This is a 10-minute built-in hold.
Ready report to enable T-minus 4 minute limit conditions. EEA?
Ready.
PEA?
Ready.
T-minus 4 minute limits on. SYS, verify alarms disabled and database modifications per redline memo and authorized real-time changes.
Was that alarms disabled?
Verify alarms disabled and
Copy.
database modifications per the redline memo.
Copy complete.
Roger. MEQ, establish has-gas scan pattern 140.
Roger.
VSE, verify active with composite ramp temperature evaluation for current plan T0.
Verified.
And VSE, verify base bending moment instrumentation is active and data is valid.
BBM system is fully mission capable. Recommend placard 6 alpha.
Roger. ALC, verify wind monitoring system set to placard 6 alpha.
Roger.
L-minus 12 minutes.
MEQ, initiate data logger just prior to the L7 poll.
Roger.
As I mentioned earlier, we'll be launching twin satellites today. Many of our missions include several satellites launched in many different ways. Last week I got the opportunity to talk with Caleb Weiss, who's our mission manager for the upcoming Atlas V launch of the Worldview 4 mission. We talked about rideshare and multi-satellite launch capability. Let's take a look at that interview. Caleb, what is rideshare?
Well, rideshare on a rocket is a lot like rideshare in a car. If you have two people that want to go to the same place, it's a lot more efficient and cost effective for them to ride in the same car than to each take their own. And so with a rocket, if we have a primary mission that has excess performance available, we can add a secondary payload and they can take advantage of that excess performance at a lot lower cost than it would be to go out and find their own dedicated launcher.
That's great. Sounds like a really cost-effective and great idea. Is rideshare a new concept?
It's not. It's been around for a long time. In fact, ULA has a long history with it. We've flown a lot of rideshare missions over the last few years. The AFSPC mission launching now is a dual payload mission, so the rocket infrastructure is all there, ready to support multiple payloads. We've done the MMS mission on Atlas, which was 4 satellites, and we've done a lot of CubeSat missions on all of our vehicles.
Oh, very interesting. It's good to know that we've had some history doing it in the past. You are the mission manager for the upcoming Worldview 4 launch on the Atlas V. Is that mission a rideshare as well?
It is. So Worldview 4 is the next satellite in the Digital Globe constellation. They had excess performance available, so they offered that to the rideshare community. And our partners at Tyvak Nanosatellite Systems found 7 CubeSats to ride with us. So we'll be launching out of Vandenberg with Worldview 4 next month. And that'll take us up to 62 total CubeSats over the last few years. We've already launched 55. And after that, it will just be more in the future. We just announced a university program where universities can compete for CubeSat slots, and we're going to be putting dispensers on Atlas vehicles more and more in the future, so we'll actually be able to offer those on a regular basis, possibly up to 2 times a year, where universities and commercial companies can both take advantage of those slots and continue launching their CubeSats with us.
You know, I actually sent out that request to my old alma mater for university, so I'm hoping some of them apply as well.
We're actually about to announce the winners very soon over the next few months for a ride in 2017.
Great.
Yeah.
Well, we're really looking forward to that.
All right. Thank you.
ESD TM2 SFI signals.
We're on 1.
Get a minus 33.5.
L minus 9 minutes.
LCFMA.
Go ahead.
Primary wind load relief file has been loaded into the RIFCA and verified internal checksum. Foxtrot 1 Echo Charlie.
Roger. All steps are complete prior to the status check.
L minus 8 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 10-minute built-in hold as preparations for the launch continue. In a few moments, launch conductor Doug Lebo will pull the launch team for the final go to pick up the countdown. 32 engineers and managers are pulled for system status and readiness to proceed. This is a final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness pull includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Doug Lebo performs the final pulling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
PNE.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
VST is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
LD.
Launch vehicle is ready to launch.
MD.
This is the mission director. You have permission to launch.
Proceeding with the count. MEQ, establish swing arm lock pins, pull.
Pulling is complete and the launch team is given the go for launch. The countdown will resume in approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 332, booster liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant tank fill and drain valves. Also at T-minus 332, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed and booster liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm booster, DCSS, and flight termination system battery voltages. At T-minus 120, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. A final launch vehicle and spacecraft status check is conducted at T-minus 30 seconds. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off the excess hydrogen at the base of the vehicle. Liftoff will occur at T0. After liftoff, we'll hear the voice of Steve Agid providing launch vehicle ascent data.
T-minus 4 minutes and counting.
Upper stage lock securing started.
Vehicle transferring internal.
3 minutes 50 seconds.
The countdown clock is resumed and we are go for launch at 12:52 a.m. Eastern Time.
Tank securing started.
3:30.
Vehicle transfer internal complete.
CBC LA suit secured.
CBC lock secured.
Second stage lock secure at flight level.
CBC pre-press started.
3:10.
Spacecraft to internal.
3:07.
Spacecraft going to internal.
T-minus 3 minutes.
Vehicle ordnance arming. Vehicle ordnance arms.
CBC locks at flight pressure and flight level.
T-minus 2 minutes 10 seconds.
Verify spacecraft internal.
Spacecraft internal.
T-minus 2 minutes.
TPA script running.
CBC
Hydraulic
LS2
press
at flight
at
pressure
4,000.
and flight level.
T-minus 1 minute 30
T-minus
seconds.
90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute 20 seconds.
Upper stage LH2 securing started.
T-minus 1 minute 10 seconds.
T-minus 1 minute.
Engine start box go.
Rock, report range status.
Range green.
T-minus 50 seconds. 45.
Launch enabled. GE main power off.
Off. Upper stage LH2 secure at flight level.
T-minus 30 seconds.
Status check.
Go Delta.
Go AFSPC 6. Green board.
25.
Flight lock in. SRM TVC blowdown.
T-minus 15.
Rofi ignition.
T-minus
T-minus
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the United Launch Alliance Delta IV rocket carrying the AFSPC mission for the United States Air Force.
Good chamber pressure on the main engine. Good chamber pressure on both solid rocket motors. 17 seconds into the flight. Good engine control in the first stage. 25 seconds in.
You are hearing the voice of Steve Agate providing launch vehicle
Chamber
ascent
pressure is
data.
beginning to trail off in the solid rocket motors as expected, as we're passing 33 seconds. Altitude passing 2.2 nautical miles. 37 seconds in. .44 seconds, Mach 1. Vehicle now going transonic. Passing 50 seconds, still looking good. 57 seconds, max Q, maximum dynamic pressure on the vehicle, passing the 1 minute mark. Altitude now 7.3 nautical miles, velocity 2,713 feet per second, downrange distance 4.5 nautical miles. About 20 seconds now remaining until the solid rocket motors burn out. Still looking good at 1 minute 20 seconds in. Standing by for SRB burnout. Burnout. Standing by for separation. And separation. With separation of the solid rocket boosters, 1 minute 48 seconds in. Now 1 minute 51 seconds. The Delta IV rocket only weighs now 1/2 of what it did at launch, burning propellant at the rate of 1,947 pounds per second. Passing 2 minutes. Altitude now 29.4 nautical miles, velocity 6,000 feet per second, downrange distance 29.2 nautical miles. Passing 2 minutes and 17 seconds, a little bit over Mach 5 now, 5 times the speed of sound. Second stage systems online now. We've opened up the hydrazine supply valve. Mission events occurring very close to their anticipated time, passing 2 minutes 38 seconds. At this time, we're coming up on the maximum fairing temperature this time of the flight. As passing 2 minutes 49 seconds, altitude now passing 48.3 nautical miles, velocity 9,687 feet per second, downrange distance 77.6 nautical miles, passing 3 minutes. Just passing through Mach 10, going 10 times the speed of sound as we continue to fly. Less than 1 minute remains on our first stage flight. 3 minutes, 20 seconds in. Altitude now passing 61 nautical miles, velocity 13,900 feet per second, downrange distance 138 nautical miles. Passing 3 minutes, 39 seconds, passing through Mach 15, 15 times the speed of sound. As we continue to fly, standing by for our partial thrust command. At the partial thrust command. Standing by for cutoff of the first stage engine. Partial thrust mode. And we've had cutoff. Standing by for stage separation. We have stage separation. The NEDS is deploying. Standing by for the igniter spark, the second stage. And we have igniter spark, standing by for ignition, and we have ignition. Ignition on the second stage chamber pressure is beginning to rise. Standing by for fairing SEP. And we've had fairing SEP. 4 minutes, 38 seconds into the flight, altitude now 90.48 nautical miles, velocity 18,706 feet.
This is Delta Mission Control at T plus 4 minutes, 47 seconds. A Delta IV rocket carrying AFSPC 6 for the United States Air Force lifted off at 12:52 a.m. Eastern Time, and all systems continue to operate as expected. At our customer's request, we'll now be concluding our live coverage. But before I sign off, I'd like to thank ULA Steve Agid for providing some commentary for today's broadcast. If you're interested in ULA and want to learn more about the Delta IV vehicle, you can go to our website at ulalaunch.com. You can also always join the conversation on Facebook and Twitter by using the hashtag AFSPC6. We'll leave you now with another look at today's liftoff. I'm Andrea Linhoff. On behalf of the entire launch team, thank you for joining us so early this morning and have a great rest of your day.
T-minus 15.
Rofi ignition.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the United Launch Alliance Delta IV rocket carrying the AFSPC 6 mission for the United States Air Force.
Good chamber pressure on the main engine. Good chamber pressure on both solid rocket motors. 17 seconds into the flight. Good engine control in the first stage. 25 seconds in.
You are hearing the voice of Steve Agid providing launch vehicle
Chamber
ascent
pressures
data.
beginning to trail off with the solid rocket motors as expected.